In today's lesson, we are going to continue with our review of factoring, and we're going to look at factoring by grouping and tricky trinomials or complex trinomials. So again, you should have covered this before last year or taken a look at something like this. So hopefully this is more of a refresher and not something completely new. So when we factor by grouping, what we're doing is it's a form of factoring. Right, so it's a different type of factoring where selected terms in an expression are grouped together. So basically we're making groups and then factored separately from the other terms. And then usually once we do that factoring, the new factors are also factorable. So it's kind of like a multi-step process. Now, a key characteristic of an expression or what we can look for to help us figure out should I be factoring by grouping would be that usually we factor by grouping when we see 4 or more terms in an expression. Right, so that's kind of a key thing to look for. Generally it tends to be four terms, but that's kind of what you're looking for. We talked about yesterday the common factoring. That's kind of something that can occur anywhere. We talked about the simple trinomials, which was the second part of the lesson, the previous lesson. And again, that's 3 terms. So generally when we see 4, we're factoring by grouping. So let's go through and factor the following. So we want to factor x cubed minus 4x squared plus 3x minus 12. So when we factor by grouping, essentially we're going to group or separate our expression into 2 parts. So we're going to look at, let me just highlight it, we're going to look at this part separately from this part. And we're going to see what common factors can I take out. So if I look at the first part that I've highlighted in yellow, what's common between those 2 terms? Well, between those 2 terms, I can see a common factor, or a greatest common factor, of x squared. X squared is the greatest common factor. It's the largest factor that's shared between those 2 terms. Now, I can't common factor the entire expression because if we look at what's highlighted in green, we can see that the x squared does not exist in those 2 terms. So I wouldn't be able to common factor. But we'll see that I can common factor the 2 terms that I've highlighted. So that's what we're going to do. So we're going to factor those 2 terms, then we're left with x minus 4. For the next 2 terms, what's the greatest common factor between 3x and negative 12? Well, there's no numbers, or there's no letters, so there can't be a letter, but I can see that there is a factor of 3. So I'm still going to put the plus down to show that I've separated these 2 terms and it carries over from up top. I'm going to put my greatest common factor for the 2 terms on the right, or that I've highlighted in green, which is a 3. And then I'm going to factor, so what's left over is x minus 4. And now so that's factoring by grouping. I've grouped my expression into 2 parts. I've factored each part separately. Now we can see that there is a greatest common factor between the 2 remaining terms. Right? So just quickly we can see that this is one term and this is another term. So I have 2 terms and there is something common between both of them. Oops. We talked a little bit about this in the previous lesson. We see a bracket that's common between both terms. I can factor that bracket out. So I take out x minus 4. And what's remaining, once I do that, is x squared plus 3. So I factored it completely now. There's nothing else I can factor. It's a final product. I don't have to worry, or there's nothing else I can do. So that's kind of how factoring by grouping goes. We separate it into 2 parts. We factor each part separately, and generally speaking, then we can factor out a bracket after that. So let's take a look at b. Let's do the same thing. Let's focus on the first part and the second part. Right? So 4 terms, we're going to factor by grouping. If I separated the first 2 parts, or the first 2 terms, what's common between 3ax and minus 3ay? Well, the number 3 for sure. And there's also a factor of a between them that is the same. So when I factor that, what's left over is an x minus y. For the second half, I'm going to put my minus in, right, to show that it's still there. What can I factor between 6bx and 6by? Well, for starters, the number 6 and the b is also common. So I'm going to factor out the b as well. That then leaves me with, we have x, and we want to be careful because we have a negative here. Sorry, my mistake. It's not 6 that's the common factor. We're actually factoring out a negative 6. The reason is that because we're looking at the sign here, we have that negative there, we want to factor that out. And we'll look at in a second of why that is. So if I factor a negative 6 out, from the second one, that leaves me with a negative y left over. So the reason we factored the negative out is because if I went through and multiplied this, negative 6b multiplied by x is negative 6bx, and negative 6b times negative y is a positive 6by. So again, that's the main reason why we're doing that. And a helpful thing to think of as well is generally when we factor by grouping, we want to make sure that what's left over in the bracket is the same as in the first set, you could say, or the first 2 expressions. Right? So if I didn't factor out that negative, I'd be left with a positive. So now I can factor again because we have a bracket that is common. So in this case then, that bracket's common. I'm going to remove that bracket, x minus y. What's left over from each expression? Well, I have a 3a and a minus 6b. And then now I've completely factored my expression. I have a product of I have a product of 2 factors, so I factored as much as possible. Try to look at C. Same idea. Let's keep the 2 parts separated. 3x to the power 5 minus 6x cubed. What's common between those 2 terms? Or is it greatest common factor? It'd be 3x3. We're left with then x squared minus 2. And if we look at the second one, there's really not much we can factor between that. But again, our goal now with factoring by grouping is to ensure that I get a product in the second term that is the exact, that has at least the same bracket of x squared minus 2. So how can I get that from looking at the second pair? Well, in order to do that, we can see that we have a negative in front here, we see a positive here, so our signs are opposite from what we want. If that's the case, I can factor out a negative 1, which would then change this to be a positive x squared and a negative 2. By factoring out the negative 1, essentially we change the signs of the terms, similar to when we used the distributive property or when we did subtracting polynomials. Now that I've done that, I can see that I have a common bracket between the two terms, which I can then factor out. X squared minus 2, that entire bracket comes out. And what's left over from each one, I have 3x cubed, and I have minus 1. So that is my entire, or my factored form, you could say. D is a little bit trickier. Right? So I have x squared minus 9 plus x squared minus 6x plus 9. So we have a couple things that we can do here. This does kind of imply that we need to have, or there is some other things that we do need to have here, so it might be a little bit tricky. So don't worry if you can't necessarily get this one. Probably actually leave this one for a challenge during the actual in-class lesson, but we'll go through it here. So the first bracket, we should recognize, or we will be able to recognize, that it's a specific type of expression or polynomial. In this case, it is what we call a difference of squares. So a difference of squares actually works out to a specific factor, which we'll look at in the next lesson. So again, that's why I'm saying don't get too disappointed if you don't quite get this part. But in our second bracket here, this x squared minus 6x plus 9, that's a simple trinomial. We did cover that in the previous lesson. So here, because it's a simple trinomial, we're looking for two numbers that give us a product, or they multiply to give us 9, and they add to give us negative 6. So if that's the case, we have to kind of think about it, maybe use a multiplication table. Two numbers that multiply to 9, 3 and 3. 3 plus 3 is 6, but I want negative 6. So negative 3 times negative 3. So I can switch the signs around there. They still multiply to 9, and now they do add to negative 6. So that means my two brackets are going to be x minus 3 and x minus 3. Now I have two terms, a product on one side, a product on another side. Is there anything common between them? Well, actually yes. One of the brackets is a common factor between the two. So I can remove that bracket, x minus 3, and then what's left over? Well, x plus 3, and then plus x minus 3. And now I've factored it completely. So it can get a little bit tricky sometimes, but we have factored it now. So again, those are some examples of factoring by grouping. Again, D was more of a challenge, but definitely A, B, and C are kind of generally what we'll see when we're factoring by grouping. Let's recall simple trinomials before we get into the complex ones. So again, in our previous lesson, we looked at simple trinomials in a specific form, and we factor it by finding two integers that multiply to give us C, or the last number, and add to give us B, or the middle number. So if I look at this first example, it's a simple trinomial, x squared plus 7x plus 12. I'm looking for two numbers that multiply to give me the last number, or 12, and two numbers that add to give us the middle number, or 7. So we think about the numbers that multiply to 12 and add to 7, should find that it's 4 and 3. Since that's the case, it becomes x plus 4 and x plus 3. Let me just color code it. So that is our factored form for that simple trinomial. For B, same idea. Looking for two numbers that multiply to give us negative 30, but they add to give us negative 1, or that middle number. Our first term will be B. The second term comes from solving this kind of riddle. What two numbers multiply to negative 30 but add to negative 1? Well, it would be negative 6 and 5. And again, you may not get it that quickly, which is okay. You're probably just going to have to maybe do some guess and check, look at a multiplication table to try to figure it out. There's not really a quick way to do it. But again, as I mentioned before, definitely focus on the two numbers that multiply to negative 30 first, and then try to figure out what numbers, or see if they add to negative 1, because there's fewer options for the product or multiplication. So B minus 6, B plus 5, those are my two factors, or the factored form of this trinomial. So that's what we did yesterday, or in the previous lesson. Now what we're going to be looking at are tricky trinomials. So a tricky trinomial is or a complex trinomial is very similar to the form that we just saw, except the key difference is that the letter in front of the x squared term, or the variable squared term at the beginning, is not 1. And so if we have a value in front, we have to factor by using a method of decomposition. So it's very similar to the method we just used, except there's one small difference. So what we're doing is we're still looking for two numbers that multiply to give us, instead of C, we're actually multiplying to give A times C, and then add to give B. Once we do that, we split B into the two numbers that we found, and we factor by grouping. So again, a few extra steps, and again, it is a more complex trinomial, or it's more complicated, so it is going to take a few more steps to go through and solve. So let's go through and factor. So I have 2x squared plus 11x plus 12. So the rules state I'm looking for two numbers that multiply to give me the product of A times C, or in this case 2 times 12, which is 24. So I'm looking for two numbers that multiply to give me 24, and they add to give me 11. So they still add the same way. They add to the middle number, or B, but they multiply now to give me the product of A times C, or the first number times the last number, which in this case 2 times 12 gives us 24. So let's go through. Let's see what we can find. Again, trial and error, using a multiplication table, whatever the case may be, you should find that it should be 8 and 3. 8 times 3 is 24. 8, oops, or not multiplication there. 8 plus 3 is 11. So normally, if this was a simple trinomial, we'd just take those two numbers and plug it into the bracket. What we're doing now is we are actually breaking up that middle number. So now this becomes 2x squared plus, instead of 11x, it will become 8x plus 3x. So we're just breaking that down into two terms. Still means the same thing. And then plus 12. Now we have four terms. We're going to factor by grouping. So if I look at the first two terms, 2x squared plus 8x, well, I can factor out a 2 as well as an x. And that leaves me with x plus 4. In my second term, I can factor out a positive 3. That will leave me with x plus 4 as well. Now that we factored that by grouping, hopefully we recognize that there is a common factor between those two terms, which is actually the bracket in itself. So I can remove that bracket, x plus 4, and I'm left with the remainder 2x plus 3. And that is factored fully. So I have everything there that's factored fully. I have a product at the end. I've taken my complex or tricky trinomial and broken it down into its factored form. Let's look at B. Same idea with B, even though we have different letters. It's still a trinomial. It still fits the form for a tricky or a complex trinomial. So that means we're looking for two numbers that multiply to give me the product of A times C, or 6 times 5, which in this case is 30. And they add to give me the middle number, or B, which is negative 17. So what two numbers multiply to 30 but add to negative 17? Because they multiply to a positive but add to a negative, chances are the numbers are both negative. So it might be helpful, just find two numbers that when you multiply to 30, they add to 17, and then just change the signs to negatives. So in this case, it would actually be 15 times 2. 15 times 2 is 30. Oh, sorry, not quite. Because 15 times 2 is positive 17. I want negative 17. So that means I have to add negatives to both of the numbers. Doesn't change the multiplication, because a negative times a negative is a positive, but it does change our sum or our addition, and it makes our final answer a negative. Once we have those two numbers, we break up that middle number. So instead of negative 17h, it becomes negative 15h minus 2h plus 5. Go through. Now what we're going to do is factor, or factor by grouping. Oops, let me just keep the color coding the same. We're going to factor by grouping. Look at the first two terms. Look at the last two terms. First two terms. What's common between the 6h squared and the, that's a 15, and the negative 15h? Well, there is a greatest common factor of 3 and an h. So I factor that out. That leaves me with 2h minus 5. In my second term, or my second bracket, I want to be able to factor something out that gives me the same thing, or the same bracket. In this case, in order to get a positive h, or positive 2h in my bracket, and a negative 5, I can see that I've changed the signs. All I've done is I've just switched the signs. That means then I needed to factor out a negative 1. So the negative 1 comes out. I'm left with positive 2h and negative 5, which is the same bracket in both, which means I can also factor that out, which leaves me with a leftover of 3h minus 1. I now have my factored form. Now you might say, well, how do I know which number to put first when I break up my middle term? And the truth is, you can put them in any order. When you factor by grouping, you'll still be able to get this two similar brackets. It might just be reversed. So for example, let's just take a quick look at that. Use a different color. Let's say I had 6h squared minus 2h minus 15h plus 5. So all I've done is I've just switched the two middle terms. If I factor the first two, I can see that there's a 2h that's common, and I'm left with 3h minus 1. In the second bracket, there is a 5 that I can factor out. But because I want to make sure that it's the same thing, I will have to actually take out a negative 5, which then leaves me with 3h minus 1. I have the same brackets, so I get 3h minus 1 out as a factor, and the leftovers, 2h minus 5, is the remainder. And we can see that we get the same thing. So it doesn't really matter what order it goes in when we break it down, because it will work out the same in the end. Let's look at two more examples, and then it'd just be some practice. So 6w squared minus 15w minus 9. Again, we're looking for a product of two numbers that multiply to give us the product of 6 times negative 9. 6 times negative 9 is negative 54. And they add to negative 15. So negative 6, or sorry, so something times itself gives us negative 54. You could look at the two numbers that we started with, 6 and negative 9. They multiply to negative 54, but they don't add to negative 15. Try to play around with some of these numbers. And again, it might be difficult to find them, so there might be something else that we have to do, because it's becoming a little bit difficult to find anything. I was just trying, couldn't really find anything. Is there something else we could have done, even before all this? Well, if I go back and look at my trinomial, I might recognize that there is something common between all three terms right away. There is a common factor already there. There's a common factor of 3 in each of those terms. So I can do a common factor first. And factor out 3. This then leaves me with still a complex trinomial, but let's try these numbers. So we're looking for two numbers that multiply to give us 2 times negative 3, which is negative 6, and add to give us negative 5. Now this is a little bit easier to solve, right? There's only so many options that multiply to negative 6. In this case, it will be negative 6 and positive 1. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. So now I have what I can break down my middle term with. So this 3 is still going to stay on the outside. 2w squared now is minus 6w plus 1w minus 3. I'm going to factor by grouping on the inside, looking at the first two terms and the last two terms. Should be able to find that we can factor out a 2w and be left with w minus 3. And in the second term, there's nothing that I can really factor out because there is a w minus 3 already. You could say I factor that out, or I factor out a positive 1. Then we can factor by grouping. original 3 is still there. 2w, nope, sorry, we're factoring out at w minus 3. And then what's left over is the 2w plus 1. And that is our final factored form. So we did have an added thing there of common factoring. So one thing you might want to make a note, always look to common factor first. So always look to common factor first. Let's do the same thing with D. Let's try to go through and look. Is there a common factor first? Well, there is a common factor between the 12 and the 3, but not the 12 and the 5, or not the 3 and the 5. So in this case, there is no common factor. So let's try to factor it as a complex trinomial. Two numbers that multiply to give us the product of a times c, or 12 times negative 3, which is negative 36. And they add to give us the two middle numbers, or the middle number, which is 5. So two numbers that multiply to negative 36 but add to 5. So again, might take some guesswork, but we should find that 9 and negative 4 work. 9 times negative 4 is negative 36. 9 plus negative 4 is also 5. So those are my two numbers. It does fit this kind of puzzle. That means I can go through, break down that middle number into those two terms. So 9x minus 4x minus 3 at the end. And now I'm going to factor by grouping. Look at the first two terms, look at the last two terms. Common factor between 12x squared and 9x is 3x. Left with 4x plus 3. In order to have the same thing in the second bracket, we can see that the numbers are the same. The only thing that we'd have to do is change the signs. In order to do that, we can factor out a negative 1. We're left with 4x plus 3 as well. Now there is a common bracket, which we can factor out. And the remainder, or the leftovers, are the other bracket. So that is how we factor tricky trinomials or complex trinomials. We have to factor by grouping. And the other thing that we learned is that you always want to look to common factor first, because that will make things a little bit easier. It'll give you easier numbers to work with, and in some cases it may not be factorable until you common factor it. So again, make sure you're okay with factoring by grouping, and then using factoring by grouping when we factor tricky trinomials or complex trinomials. If you're not too sure, you're not quite that comfortable, make sure you are practicing, make sure you are kind of following these steps along. Play the video as you go through and solve it if you need to, or make sure you are trying to get some extra help.